Hmm. Acha, before to start sound waves, right? I feel that I need to discuss the concept of waves, right? For example, when we when we talk about sound waves, okay? So do you think that sound waves cannot directly be started? Because before sound waves, the student should understand the concept of waves, right? Concept of waves, that what waves are, right? And then we should understand the types of waves. Okay? Types of waves could be transverse waves, transverse waves, right? And longitudinal waves. Okay? ठीक है ना? So then we will be able to start sound waves. Okay? All right. So I need to discuss general wave, yeah, general properties of waves. Okay. uh, General properties of waves, right? Acha, in general waves of properties, we are going to understand that waves transfer energy without transferring matter or material. Okay. For example, uh, when we speak, right? So, do you
Yes.
think while we are speaking, our organs or our matter, body organs, or some of the part of the body also travel along with the waves? Do you believe, or do you think, does this happen?
No.
No. Okay. So it does not happen that our organs or the sound box or other organs that are involved in producing the sound waves, okay, they also travel. It does not happen. Clear? So this is the
Hmm.
concept that we are going to develop this understanding that waves transfer energy. Okay, waves always waves always transfer energy without without transferring without transferring matter or material, right? For example, you must have seen that when we if I have a string, okay, a string, okay, there's a string, and the string is uh connected with the both ends with the fixed support. Okay. Now see over here, I have a rubber band, right? I
Mhm.
have taken a rubber band here. So what are you observing? That someone has disturbed this rubber band from any point, and the rubber band, is vibrating. Okay.
Yes.
Okay. So again, do you think that rubber band is being transferred to other points, or is it moving from one point to another point? Is it traveling? No, it is not traveling.
Mhm.
But for example, if I disturb the rubber band, okay, when when the rubber band gets disturbed, so the source the source of disturbance the source of disturbance the source of disturbance does not uh transfer or transmit. आपका हाथ तो कहीं इधर से उधर तो नहीं चला जाता ना भाई? एक जगह था और आपने डिस्टर्ब किया, अब हाथ निकल गया, कहीं और चला गया, वेव्स के साथ ही चला गया. हाँ, डज दिस हैपन? नो.
No.
ठीक है. सो we need to understand whenever waves are produced, they they transfer energy, number one, and number two is without transferring matter or material. Okay, are you getting my
Mhm.
point? ठीक है.
Yes.
So whenever there is a disturbance in the medium, ठीक है, when I say disturbance in the medium, so whenever there is a disturbance in the medium, so what do you understand by medium? When there is any disturbance in the medium. Acha, medium means any material. Okay, it could be an object, right? Or I must say state of matter. Clear? When there is any
Mhm.
disturbance in the medium, disturbance, how would you bring the disturbance? You just, apply a force. Okay, you apply force on
Mhm.
anything. Like if you have a spring, you apply force on the spring starts vibrating. Okay, so I have used this word vibrating means that it is going and it is coming back. Okay. Okay. So
Mhm.
whenever there is a disturbance in the medium, so the mechanical waves are produced. Is this clear now? ठीक है.
Yes.
Acha, so how the waves transfer energy? How waves transfer energy? How waves transfer energy? जी, अब तो हमने ये सीख लिया कि अच्छा वेव्स बनती कैसे हैं. Whenever there is a disturbance, the waves will be produced. ठीक है. The second part, how waves transfer energy. जी, any idea?
No.
अच्छा, all right. So do you think that whenever we disturb any medium, ठीक है, तो medium includes the particles as well, right? ठीक है.
Mhm.
So do you think that particles start vibrating?
Yes.
ठीक है. All right. So the very first thing that you need to understand that particles always vibrate, okay, in order to transfer the energy.
Hmm.
Okay?
Yes.
So if you apply more force, so do you think that more energy will be transmitted from one point to another point?
Yes.
Okay? So let me show you one thing here. See this thing. So what are you observing? The two persons are, carrying a string or a kind of rope. Okay.
Hmm.
So there's a disturbance. When they disturb the string or rope, what happens is the energy gets transferred. Now, from where the energy is coming?
Uh,
From
it's
the source. Yeah,
from
for
the source of the servants.
exactly. So source of the disturbance is the person's hand. Okay, so this
Hmm.
question comes in the exam, that what is the source of vibration here, or what is the source of the waves? So you will write the hand. Okay, okay, hand of the person. Okay, right.
Yes.
So now see, if you apply more force, so more number of waves will be produced. Okay,
Hmm.
and if you apply less force, okay, if you apply less disturbance, so you will have less number of waves, right? So are you getting
Yes.
my point? Here more waves are involved in the same distance from one point to another point. But over here, keeping the same distance and keeping the same length of the rope, the number of waves are less, right? Why this is so? Because the less force is applied. That means less disturbance is created. Okay. So what happens is
Hmm.
the more energy will be transmitted from one point to another point when there are more waves. Is this clear?
Yes.
Okay. And if there are less number of waves, so there will be less energy. So it depends that if we want to transfer more energy, we have to create or we have to develop more disturbance. Okay. Is this clear?
Yes.
Okay. All right. Acha, does this happen when we throw a stone on on a uh on that area where water is there? Okay?
Sorry.
1 minute. So what are you observing in this picture? G. In this one, what are you observing? The stone is dropped, right?
Hmm.
The stone is dropped. So what do you think? What is going to happen? If
The
I throw,
water
yeah, the
passes.
water waves are produced. Okay? The water waves are produced,
Hmm.
right? So
Yes.
you drop the water over here. Okay? You drop the water over here, and the waves are produced. Okay? So if more waves are produced, that means more energy is being transmitted from one point to another point. Is this clear now?
Yes.
Okay?
Yes.
सो दैट मीन्स आजकल जो हमारे सी साइड पर, ठीक है, जो इमरजेंसी अप्लाई हुई भी है, ठीक है, अकॉर्डिंग टू द जो भी आपके कानून और रूल्स हैं, ठीक है, सो इफ मोर वेव्स आर कमिंग, if more waves are coming, that means more energy is being transmitted to this point. Clear? If less
Hmm.
number of waves are coming, that means there are less energy uh, is received at this point. ठीक है? I hope this is clear
Yes.
to you. Okay? ठीक है?
Yes.
All right. So it depends that how you create a disturbance and how the particles are vibrating. So how waves transmit energy through vibration of the particles. Clear?
Yes, correct.
Oof, no. Uh, how waves transfer energy. The first point is through disturbance. The waves are formed. The waves are produced. Second, they transfer they transfer energy. They transfer energy uh, through vibrating particles. Through vibrating particles. This is the main core idea of the energy transfer. Okay, so they transfer energy through vibrating particles. Is this clear? Okay, right?
Yes.
So how the particles are vibrating? Particles, yes, medium. When we say medium, that means particles. Clear? When we say medium, that means particles. Particles are vibrating. You need to disturb the particles. So what is going to happen? The particles are going to vibrate. Okay? So vibrations are of two types. Okay? Either vibration can be parallel to energy transfer or perpendicular to energy transfer. To energy transfer. So let's unpack this concept. G. Parallel to energy transfer or perpendicular to energy transfer. Okay. So I'm going to show the concept of how particles are vibrating, okay, parallel to energy transfer, and how the particles are vibrating perpendicular to energy transfer. Okay.
Yes.
Now have a look on this, right? So we are going to understand that over here, what are we observing? See, when a mechanical wave moves through a physical medium, the particles in the medium oscillate. Oscillate means vibrate, okay? In a simple harmonic motion. Okay, let's leave this simple harmonic motion. It's not a part of our syllabus. Okay, but over here you can see that this particle is moving up and down. Okay, so in the same way, the energy is being transferred. Okay, energy is being transferred in this direction. Okay, in this direction, right? So let me uh, annotate so that it will be easy to understand. The energy will be transferred in this direction. Okay. So this is your energy transfer, direction of energy transfer, direction of energy transfer, right? And this is your vibration. Okay. And vibration is always shown with the double-sided arrow. Okay. Vibration of the particle is always represented by the double arrow. Okay, double-sided arrow. This is clear? And the single arrow, okay, is denoting is representing direction of energy transfer. Okay, is this clear? Okay, hello, is this clear?
Yes.
All right, so let's understand over here. Lot of springs, many springs are attached, right? And they all are vibrating. ठीक है, why? Because the particles are vibrating. ठीक है, अच्छा जी. Now, a wave in which particles of the medium move parallel to the direction of the wave. ठीक है. So uh, in this model, you can understand, you can see here, the particles are vibrating. ठीक है. The particles are vibrating. Okay, my God. Okay, okay, okay. All right, all right. I got it. I got it. I think I took it wrong in above model, right? The energy is not being transferred from top to bottom, but it is being transferred from left to right, or you can say from right to left. Okay. Now, you can imagine a rope, right, or a string. When you create a disturbance, okay, when you create a disturbance, so creating a disturbance that you vibrate the particles up and down, but the string is you know is is moving in this way. Okay, right? So energy is being transferred to the right side. Energy is being transferred to the right side. And what is the direction of the particles of the vibration? Yes. What is the direction of the vibrating particles? Up and down. The direction of the
Anton.
vibrating particles is up and down, and the energy that transfers from this point to that point is in this way, from left to right. Okay. So this is how we can say that energy is transferred from left to right, and the vibration of the particles is up and down. So they are perpendicular. Okay. Vibration, vibration and energy transfer is perpendicular. Perpendicular means having 90-degree angle. Clear? Okay.
Yes.
Can you see the particles? This particle is vibrating up and down. This particle is also vibrating up and down. This particle is also vibrating up and down. But they are transferring energy from left to right, making 90-degree angle. So this is how the particles are vibrating perpendicular. Perpendicular word is also used. Okay? Instead of using 90-degree, you can use
Mm,
perpendicular word. Okay? Now, another model that represents the particles vibrate parallel to the direction of energy transfer. I'm using parallel word. Okay. This time you can see here particles are vibrating right and left. Okay. Back and forth. Particles are vibrating back and forth. That means right and left. Is this clear? Okay. And the energy is also transferred from one point to another point. Are they making 0-degree angle, or we can say that they are parallel? The vibration and energy transfer and energy transfer. They have 0-degree angle. They have 0-degree angle. Clear?
0 degree.
So I can say that particles are vibrating. Particles are vibrating parallel to energy transfer. Is this clear?
Yes.
So there are two types of waves. Number one is transverse wave, and number two is longitudinal wave. Is this clear? One is transverse wave and one is longitudinal wave. Transverse wave, transverse wave, the wave, the wave in which, I mean, why am I writing? Okay, why am I writing? Since the definition is written here, so you can, note down this one. A wave in which the particles of the medium, okay, the particles of the medium move or vibrate, move or vibrate, okay. Perpendicular word is the key term. Perpendicular word is the key term. Clear? Perpendicular to the
Mm,
direction of the wave. Perpendicular to the direction of the wave, or the wave propagation, or transfer. Okay? Or energy transfer.
mm,
Perpendicular to the direction of wave, or I can say energy transfer.
mm.
I hope this is clear. Okay? And
Yes.
another type of wave is the longitudinal wave. Longitudinal wave says that a wave in which particles of the medium vibrate. Okay, instead of writing move, you can use vibrate. Clear? Particles or medium, particles vibrate. Parallel here, the parallel word is the key term. Parallel to the direction of wave motion, or what you can say, energy, energy transfer. Clear? Beta, is
Yes.
this clear? Okay. Okay.
Yes.
All right. All right. So let's see that how the waves, transfer energy due to the vibration of particles. Say it. So here's the model. You can again search on FET simulation. Okay. I'm going to play this. Okay. I'm going to uh play this. So this speaker will produce a sound. Let me check that if the sound can be shared as well. Okay. Can you see? Hello, can you see? Yes.
Yes.
All right. Let's see the model of particles. Now, particles are vibrating. Yes, particles
Mm.
are vibrating. Okay. Acha. Now, what if I increase the I decrease the amplitude? Gee, what if I decrease the amplitude? So, what are you observing? Particles are not able to travel longer distance. Yes, they
Yes.
are they are close to the source. They are close to the source of the sound or waves. Is this clear? When I increase
Yes.
the amplitude, so they will be able to travel more distance from the source of sound or a waves. Clear?
Mm.
Okay. Now, if I increase the amplitude, that means more distance is traveled by each particle. Okay.
Yes.
Right? Acha ji. Now, keeping the amplitude same, if I increase the frequency, if I decrease the frequency, try to imagine what is happening here. Can you see a pattern of waves?
Mm.
Yes.
Yes.
Okay. So, are they separated with the more distance or less distance? See the difference. Yes, beta.
Yes.
देखें जी. Let me explain you. When I have when I have frequency, when I have less frequency, ठीक है? When I have less frequency, so what is happening? What is happening here? If this is the pattern that we are observing, ठीक है? ये देखो ना, एक पैटर्न ये रहा, फिर एक ये रहा. Clear?
Yes.
ठीक है? So when I increase the wave frequency, when I increase the frequency, so what are you observing here? These waves come closer,
Yes.
है ना?
Mm.
These lines, you can say circular lines or simple lines, okay, or waves, they come closer. So
Yes.
increasing, that means increasing. Beta, this concept will not be repeated, so it's better you should note down in your journal. Okay, increasing frequency means uh, particles will will collide more and they come closer. Okay, okay, and decreasing frequency, it's going to be the reverse process. Decreasing frequency means that collide particles collide less and they go farther. I
Mm.
hope I hope this is clear. Is this clear now?
Yes.
ठीक है जी?
Yes.
So you can search this yourself and you can perform it later. ठीक है? After this class. Hope you have enjoyed today's class. Okay जी? Allah Hafiz. Assalamu alaikum.
I love it.